Okay, students, I've had requests for explanation for problems 36 and 37. This will probably have to be two separate videos, but each video will be me explaining how to do the problem. So for 36, we have a block hanging from a ceiling by a massless rope, and then a second block attached to the first hanging below it on another piece of rope. So 1 and 2. Both blocks have a mass of 5 kilograms. And what's the tension in each rope? So mass of 5 kilograms, mass of 5 kilograms. And maybe I'll call this rope rope number 2 and this rope rope number 1. So I'm going to look at each block individually and see what's happening. If I look at block number 1, I see an upward tension, which I'm going to call tension of rope 1, and then a downward tension of rope 2, right? Rope 2 is touching block 1 and pulling down on it because block 2 is attached. And then block 1 also has its own weight 1. So there's two things touching block 1 here and here, and then block 1 has its own weight. If I look at block 2, I see only one thing touching block 2, only tension 2, only rope 2 touches block 2. And then block 2, of course, has its weight 2. The weight of block 1 is its mass times G. I should have written the equation first, right? This is the equation for switching between mass and weight. So block 1's mass is 5 kilograms and G on Earth is 9.8. So this is 49 newtons. And really, block 2, weight 2, also has a mass of 5 kilograms. And so weight 2 is also 5 newtons. So I can now kind of fill in some things, right? Weight 2 is equal to 5 newtons. Weight 2 has to be in balance with tension 2 because block 2 is just hanging there. So T2 is 5 newtons. Then weight 1 is 5 newtons. Sorry, not 5 newtons, 49 newtons, excuse me. 5 times 9.8 is not 5. 5 times 9.8 is 49. 49 newtons and 49 newtons. Weight 1 is 49 newtons. This tension 2, is the same as tension 2 here, right? These tensions, T2 and T2 in the two diagrams, are the same thing. It's the same rope. So T2 is 49. And then here, when I'm looking at block 1, I see two different 49 Newton forces downward. So that means T1 has to support both of those forces. T1 equals 49 plus 49 newtons, so that block 1 is also at rest in equilibrium. I don't know what 49 plus 49 is. It's 100 minus 2, 98 newtons. So I have to think about each block, and I have to kind of work backwards from the lowest block up to the highest block, using the idea that each block is in equilibrium. Okay, and so I now know that T2 is 49 newtons, so that block 2 is in equilibrium. And T1 has to be double that because T1 is pulling against both block 1's weight and block 2's weight transmitted through T2. Please don't hesitate to email me with further questions about this problem if my explanation didn't quite make sense. And now I'll make a separate recording for number 37.